morning, students. Today we are going to see about third unit, sequential logic circuits. So sequential logic circuit, you know that output will be depends on one, not only the present input, output also depends on one more concept called a memory. So it will be recall your past inputs. So whatever the output is produced in the last one, that will be the present input, right? So that it will be considered as a past input. So it has to recall, so it require the memory elements. So output depends only on present input is called combinational. Output depends on both present and past output is called your present input and past output is the sequential. So it is going to be recalled, so memory elements is required, and it is also called as a regenerative circuits because it is going to be generate again and again. But in your combination, it is not going to be generated, so it is called as a non-regenerative diagram. And the simple block diagram explanation. An example for combination is mux, demux, adder, subtractor, encoder, and decoder. And for sequential, it will be latches, flip-flop, register, counters, and all type of oscillators are comes under the example for sequential logic. The next difference is going to be study about the latch and the flip-flop. So latch is a level trigger and your flip-flop is the edge trigger register. So you consider if you have the waveform, clock pulse signal, you have the waveform is like this. This is called the level portion, and if it is a high, it is called positive level, and down will be called as a negative level. And the same way, this will be called as a edges. So it is zero rising from 0 to n 1, so it will be called as a rising edge. This is going to be down 1 to 0, so it will be called as a falling edge. Otherwise it is called as a positive edge, and this one is called as a negative edge. So these are the edge trigger flip flop. When that clock is 0, clock is 1, according to that you have get the outputs. So simple representation is the flip flop is D, and normally we are preferring the D flip flop, D clock, and the Q. So if I give like this, it is called as a positive latch. That if I give the bubble here, it will be the negative latch. And if I use that corner like this, means it is showing that edge. This symbol is showing the edge portion, right? So it is called as a edge. And if it is along with the bubble, it is called as a negative edge triggered waveform. So consider positive latch means whenever the clock is positive, this portion, whatever the input we are giving, that will be reflected in the positive latch, and negative latch, it will be in the off condition. And the same case will be reverse thing for the negative latch diagram. Negative latch positive portion will be the 0, and negative portion, whatever the input you are given, that will be reflected in the output screen. This is called as your positive latch diagrams. Thank you, students.